Well, welcome friends into the Great Atmosphere show here today on January 19th of 2024. Wanted to get you started off with something really interesting. We have some succeeding mesovortices that have popped up on radar here over the spine of Lake Michigan. A relatively rare event that has these little rotating, very weak supercells forming right along the center of the lake. You don't typically see, obviously, such cool features like this, and here's a little bit of a better view of them out of the Gaines Township radar. Super duper cool. I mean, like, imagine, I've just taken a look, looking at the radar as you wake up today in the Great Lakes region and see that coming your way. It's certainly cool. And radar itself is just a fascinating thing in that of its own right, because not even 60, 70, 80 years ago, during the Great War, radar was mainly there to detect incoming aircraft, and weather was essentially a cool side effect, it's like a cool perk. And now to see how radar has evolved and how it's primarily used for weather, at least here domestically, and we get to see cool things like this that we definitely wouldn't be able to see otherwise. No one's living out here in the middle of Lake Michigan, so just really, really cool. And as far as like the phenomenon itself, it's formed by this. So it's two converging air masses at the same elevation level. So it's not wind shear in the sense of like, we have at the bottom and the surface we have winds going to the southwest, and in the mid levels we have winds going to the southeast, and that's wind shear, right? We don't have that. These are two converging wind masses at the same level at the surface, right? And the only way that they can go, if they're at the surface and they're converging, is up. And if air is being literally forced up, well, that's one thing. Well, also, where is this air coming from? Where are the winds coming from? They're coming from cold continental air mass, right? So this is very cold air. This is very cold air here on Michigan and into Wisconsin, but over Lake Michigan, it is generally ice-free, and water takes a lot longer to cool down over time than land does. So this is generally warm waters, like a warm surface layer, cold over top, and the air masses at the surface are obviously converging, and the end result are these super cool mesovortices. So that was today's cool weather observation. Just moving ahead, this is what we have. This is our current predicament here, at least on the eastern seaboard. We have a pretty significant snowstorm that's made its way over into the mid-Atlantic states. At first, sorry, I'm jumping around here. At first, there was some consensus among most of the National Weather Service folks and some private sector PhD level people that were saying that this would be more of a it'd be more of a system that would center around the northern Jersey, east central PA, and it would deliver the first big snow into New York and the southern tier of New England. That doesn't seem to have panned out that much. Actually, it's moved a little bit further south. Don't know why it's just left there. There you go. So now it's definitely affecting more of the downtown Philadelphia region, northern parts of Delaware into Wilmington, and actually impacting the D.C. area quite a bit as well into Baltimore. And I have several colleagues that live in the Sterling, Virginia area. They were only expecting 1 to 2 inches, which was what the National Weather Service was predicting initially, but things change. Weather forecasting is very difficult, specifically for snow and specifically in the northeast of the United States. Quite difficult to differentiate between 2 to 4 inches of snow. It's like predicting whether you're going to get 2/10 of an inch of rain or 4/10 of an inch of rain. And no one's coming down, knocking down weather forecasters' doors if they all of a sudden receive 4/10 of an inch when it was forecast to be 2/10 of an inch. But when it comes to snow, especially for snow-starved regions of the world, such as the eastern seaboard of the U.S. in recent years, that's the end result that we get, unfortunately. It's just part of the job. So that main force of the system should be moving out here in the next 24-36, with some flow coming in from the lakes impacting the Allegheny Mountains. Let's see what their probabilities of snow totals are. Not up to a foot, not even up to 8 inches. 6 inches? 6 inches we might be talking. So 6 inches of snow possible, maybe even a little bit more in some pockets of the Allegheny Appalachian region and central West Virginia. Let's see what impacts are around there. A lot of state parks in this region. Generalized Appalachia. So that's the current state of the snowstorm. We can take a look at what our current temperatures look like. Actually, we'll take a look at radar so we can see. This is the primary time that the snow is impacting pretty much all of Jersey. We see some light snow up into the upper portions of New York, of the New York Metroplex, and the southern tier of New England. Mountains are generally blocking most of the flow, getting into the Piedmont of Virginia and North Carolina. But on those windward-facing slopes into Kentucky, Tennessee, Murfreesboro, Bristol, that particular eastern region of Appalachian, Kentucky, and the Cleveland area actually is getting quite a bit of lake effect banding right now. So that's what's going on at the moment from a radar perspective. We'll take a look at temperatures and what they're currently looking at right now. We're still very mild in the southeast, low or mid high 40s, along the Blue Ridge Escarpment, going up into the DC area. 60s on the coast. This is generally because we've had that high pressure system that has sat off of the edge over here. It's been temporarily advecting quite a bit of warm air from the Gulf that has created us to be a little bit more mild as we go forward. But that will not, these mild temperatures will not last long, as we'll see shortly. Looking at the All Hazards Index, we can see generalized the winter weather advisories and winter storm warnings have moved south compared to what they were predicted to be yesterday. And then we also have our wind chill advisories dominating the majority of the Mississippi River Valley, Ohio River, all the way into the Central Plains, with hard freeze warnings all the way down to the deep south. That'll be as some of the it'll definitely will break some records going into both tonight and tomorrow night for the southeastern tier of the U.S. Also, I should mention that the area up in the Pacific Northwest that hasn't really gotten a ton of attention, but I've been saying multiple times that they've been under blizzard warnings, ice storm warnings, some kind of winter weather advisory or warning for essentially 2 weeks straight. And some of the photos that are coming out of there, I don't have any to share because I haven't gotten permission from any of them to use. But it's very likely that is going to be the first $1 billion damage natural disaster event in the U.S. for 2024. Some of the pictures were quite startling. The entire I-5 corridor is pretty much just at a standstill, devastated right now due to the ice, just nonstop icing that's happened. Some areas receiving well over half an inch of ice, if not even, if not more, which is absolutely crippling to any infrastructure, no matter how prepared you might be for it. So we'll be looking to that to see, how they pick up the pieces, and hopefully they get some warmer air so we can melt them out. Looking at the 24-hour accumulations so far from the National Weather Prediction Center, it seems like this generalized banding, we have seeing some pockets of 4 to 6 inches. Looking into the DC area, DC seems to have recently gotten the most hit in terms of snowfall. Looking at about 3 or 4 inches at the moment. Generalized all of PA, central and points east or west. Sorry. I've received about 2 to 3 inches, so not the biggest snowmaker by any means, and we predicted that. Didn't see a lot of convective energy, wasn't a whole lot of moisture, since the moisture is generally coming off of lakes and not the Gulf Stream in the Atlantic Ocean. That is specifically why we have not seen, in addition to the trough pattern, it being a positively tilted trough like this, has not produced as much energy going into the system as we would if they wanted a big old snowstorm or a blizzard or something like that. And this is just a nice snowfall. It's a good thing to get a nice tame 4 to 5 inches, and they won't have to deal with impacts of the snow in terms of keeping it on the ground for long, because as we'll see with temperatures coming next week, any snow on the ground in the eastern seaboard will not be there long. Taking a look at what we're looking at from the NAM 3-kilometer high-resolution model. We will go forward in time just a little bit. Let me move that out of the way. We see generally as the low starts to move off into the mid-Atlantic coast, off the mid-Atlantic coast, we see the flow starts to begin to become solely off at the lakes. See some lake effect snow coming off of Lake Superior over the UP. UP has gotten hammered with snow recently, and Lake Michigan also. We have some fetch coming off Lake Huron, going down into the southern portions of Ontario, into the Toronto Metroplex, before Buffalo. Pretty much a generalized lake effect snow storm that will affect the entirety of the Ohio River Valley through north central Indiana and Ohio into West Virginia, Kentucky, before reaching the Appalachian Mountains and getting blocked. So we'll move forward in time. That will eventually shut off as the low starts to fully move off of the coast. And then we're left with high pressure. This is some of our coldest air that we're going to see will be on Saturday night, early Sunday morning, and you can see why. Directly under high pressure, diverging air at the surface coming down from the very, very cold upper layers of the atmosphere that's been just advecting in Arctic air, not even polar air, Arctic, straight from northern Greenland. And that will just be sitting on top of the southern or southeastern tier of the U.S. For a good 24, 36, 48 hours for the majority of the weekend, unfortunately. It'll be nice and sunny, but no one will want to go outside. It'll be generally way too cold. And then we see as that high starts to gradually move off to the right, the beginning of our next week troublemaker. Will start making its way into central Texas, and you could tell for the majority of this time, the West Coast has just been receiving just flow in from the North Pacific jet. Is essentially coming in, kind of in like this kind of fashion, and whenever it's kind of spread like that, that's just essentially, it's not an atmospheric river per se. It's a different kind. It's nothing with a particularly good amount of forcing or anything to it. It's just a moisture flow that it's stuck in. So the entire West is just getting inundated, whether it be snow or rain. It's a pretty wet time to be on the western side of the U.S. And we can see what this looks like in the Pacific. This is looking at total precipitable water from the MIMIC satellite. And this is just a kind of a slice. If you were to take a slice of the atmosphere, or take a cube, square cube, or cubic meter, I guess, of the atmosphere at any particular time in the atmosphere over these areas, this just determines how much liquid water would be in that cube, based off of where it is currently. So you can see down here there would be a lot of water in that little slice of the atmosphere, and areas up here in the continent of Canada there would be very little water. And this is how we kind of see systems as they evolve. You can see just how active the Pacific is. Little low cyclones just forming one on top of the other, just impacting the West, generally speaking, throughout the course, and just hammering it over and over and over again. Now, the primary teleconnection that we like to look at is the North Pacific Jet phase diagram. And what the North Pacific Jet is this. So this is looking up at the upper levels of the atmosphere. There is always generally a North Pacific Jet. The Pacific Ocean is too big in the North Pacific to not have one. But where that jet is placed in relation to the equator, the poles, and the two primary continents of Asia and North America determines a lot in terms of the downstream weather. And since in the mid-latitudes, downstream of the jet is the Americas, it matters a lot more to us than it does to the Asian subcontinent. So what we look at generally when we're doing this is we cut it into fourths, right? Like so. And this is not a accurate depiction of where that cross would be. But essentially we'll have our equatorward, we have our poleward, and we have our eastward, and we have our westward. And anytime that it goes back to the west, we call it a retraction. And anytime that we see it extending to the American continent, we call it an extension. And very different weather patterns evolve based off of where this jet maximum, this big white area, is. So right now the jet max is on the end of an extension. So you see it's way over here, pretty much right off of the California coast. And what that does is it's just delivering constant energy for these systems that we saw earlier to be able to propagate and be able to impact the West. Eventually, though, sometimes at the pole sometimes the jet will start to retract and go back towards the Asian subcontinent, which really calms this area quite a bit down and creates much more mild, calm, dry weather for the West Coast. And ultimately, because the West Coast is upstream of the East Coast, where we are, that usually just means calmer weather in general. So when the jet diagram is right on top of us, and if we want more cold weather, we want it to be further to the poles, so it advects in more cold air. That is what we're looking at, and if it's way down here and way down to the south and east, we would expect to have warmer and drier weather. And what we do to measure this is the North Pacific jet phase diagram. So right now, where the current position of the jet is, it is technically in an extension, and it is more towards the equator. Okay, so that's why we are currently seeing warmer weather that's coming our way in the next 5 to 6 days. And then also in the west, at least, we're going to be seeing calmer weather that'll be coming our way in that same time period. And in the east, we usually don't see a connection for about 10 to 14 days, which is reflected based off of what the weather predictions or the climate prediction center is thinking. We're thinking more warm and dry towards the very end of the month for us in the southeast. And this is, I would say that's primarily attributed to where this North Pacific jet diagram phase extension is, because as you can see, it is moving. This is a ensemble view. So anytime that there is red simulates high probability or high confidence. So we could say with some certainty that by January 24th, so that's 5 days out, they have some pretty high confidence that if you look at this from a Cartesian point of view, that the jet maximum will start to move more towards a retraction. Not a full retraction, but definitely more of a retraction. And then it'll start moving more in the direction of the poles. Right. So we can expect then over the course of time, and really we're still very far away from a poleward shift. We're still well within the 2-unit diagram of an equatorward shift. So it'll still be delivering warmer air in general. Warmer air and milder air is definitely within the realm of possibility. Beyond that, I really don't pay attention to anything beyond anything that's red or orange. If you get, I know that the ensemble is saying that it's going to be making another way to to a jet extension, which would destabilize our weather. I might be in agreement on that because we seem to be in that kind of a long-term pattern, but ultimately that's too low confidence for me in this particular guidance for me to say one way or the other. But it's certainly something to keep in mind when we look at other teleconnections down the road and the long-term forecast range. So let's see what we're going to be expecting actually in terms of next week's weather, because it does look quite unstable. So we see our current system, and this is the GFS on the left, the Euro on the right, and we're going to move forward in time. We see that high pressure system start to really dominate across the entirety of the southeast, and then all of a sudden the Gulf starts to open up. And by that I mean that we have our high pressure system right here giving anticyclonic motion that's going to be ultimately driving a lot of warm and moist air up and around it. Now, another thing that's interesting is we have another very strong high that's up in the Canadian Prairie, and it's also doing this, but look at what the end result is. So we have high here, anticyclonic in both, but they're at alternate points of the American subcontinent, so their winds are going to be going against one another based off their positioning. So we're going to have winds that are going to be going like this, and then we're going to have winds that are going to be going like this. And that is typically the opportunity for a big shear event to spark some convection. So that's going to be an area, and this is all dry cold air, very dry cold air, and this is all warm moist air. So this is generally an opportunity for some potential icing. This is where we would see upper levels of the atmosphere being very cold, falling down, and either freezing at the surface or sleeting, something along those lines. That portion of the Midwest could be in store for a little bit of a surprise, and we see that actually reflected in both models. GFS a little bit more bullish in terms of the overall convection, as it typically is, based off of its recent guidance. So what's that timing? That looks to be Monday, Tuesday of next week. High pressure still dominating us here in the Carolinas and the mid-Atlantic coast. But as we move forward into the latter parts of the week is when everything starts to kind of break down. We'll have a general rain shield that'll go over the majority of the southeast. Some high elevated areas of convection that I know I'm particularly concerned about, specifically based off of some of the perturbations that I've seen in the vorticity maps on some of these model guidances. Definitely something to keep an eye on, but we'll move forward, and it's just going to be a super soaker for a lot of regions here in the southeast, starting on Wednesday, boom, through Wednesday night, Thursday, and this is a generalized probability map of where we would expect precipitation. So if it's like scattered like this, the GFS might, it's scattered on the GFS, but we have stronger areas of convection. That kind of simulates convective mode, so it's thinking more of a supercellular type of system, not necessarily a big rain shield, and the Euro is predicting more of a overarching precip event. We move forward into Thursday, same deal. It's just going to be one after the other, with even some. We're going to have to talk again about say a northeastern icing event. But look at, I mean, like these areas have been cold for so long, and now they're receiving rain, and that just kind of simulates the warm air that this is also going to be advecting in. Finally, it looks like by the end of Saturday, maybe Saturday, Sunday, yeah, there's still, I mean, the Euro has it all moving out up, and it has the low closing off, occluding and moving off into Greenland, but the GFS seems to want to hang on to some precipitation, so it's going to be interesting to see what its thinking is regarding that before we move into next weekend. So certainly, for us in the southeast, I'd expect Wednesday onward, it'll start getting warm sooner than that, more mild, I'll say, by comparison to what we've experienced recently. But ultimately, the wet weather will certainly be making its way through on the latter half of the week, next week. And we'll take a look at some of the precip totals that the Euro is expecting through next Sunday. We have some regions of the southeast. I know here in Charlotte, looks like another 3.5, 4 inches, and that extends all the way back out to the Mississippi, all the way into West Texas, into Central Texas. New Orleans and the southern coast of Louisiana seems to be getting hit quite a bit, and the GFS is even more bullish. This is some crazy amounts of precipitation that it's predicting for the Houston area, which we all know is very flood prone. Lake Charles, Baton Rouge. The central portions of Louisiana is where it wants, and that is reflective of the convective banding that it's predicting. So some training supercell thunderstorms over this region could be particularly devastating if the GFS holds true, whereas the Euro is much more of a precip shield event. Not a lot of severe convection in the eyes of the Euro, but of course it is very early. This is looking out way too far. Not way too far, but it's certainly within the realms of the flagship models, at least, to be able to see out ahead. And we can see what our surface heights are going to be looking like according to the GFS. Maybe we can look at and see where its primary perturbations are looking to be. So we have that high pressure. Yep, so here's the high. That sits right over the southeast, right? And then now begins the upward or the northward motion of the warm and moist air as it goes all the way up into the Great Lakes. And we move forward in time, and we can see kind of what it's thinking. This is the icing of the Midwest right here. So you can see there's a lot of flux in terms of what wind directions are going to be in place as it hits the Midwest. That's why there's a lot of uncertainty about the precipitation mode and type as we go into Monday and Tuesday. And we'll go into Wednesday. High pressure still sitting off of the Carolina coast, and we'll start to see the beginnings of these perturbations that pop up. And you see there was quite a significant one there, a big shortwave trough, or shortwave troughs that will be kicking off quite a bit of convection, according to the GFS. And they will continue to just kind of pop up and gradually move off to the east as you move forward in time. This is next Saturday, according to the GFS, and I wouldn't trust really anything beyond that. But we can compare the severity indexes between them both by looking at the 500 millibar height anomalies. This is looking out to, let's start it at Tuesday of next week. So what the Euro is suggesting is our primary energy kicker that'll be coming will be originating here at the crux of the Gulf of California. And then it'll be gradually, and depending on where this low moves will determine how severe of an index we would kind of attribute to it. So if the Euro is, generally speaking, going to predict less of a severe event, I would generally predict it to be going in more of this kind of a direction. And the GFS, which is more bullish on harsh convection, would probably dip down a little bit further south and create more of a steeper gradient between these geopotential height lines. So we'll see if that rings true. Yep, and we can see that the GFS already has a much stronger gradient in terms of, and a deeper low that it wants to form on the southern tier of the Rockies. Let's see how it evolves over time. So this is the Euro. Euro dips down pretty further south, but it's still not a very strong low. GFS is further north. It weakens a little bit. So that's interesting to denote. And then we have Thursday. Euro sinks down further low, seems pretty weak, and GFS honestly evens out a little bit, but it's these shortwave troughs that it's having a hard time differentiating between convection. So not entirely convinced then that the GFS has an exact hold on this yet. This would kind of give me more confidence in the Euro based on the low, even though a weaker low that drags south like this, you can see how the isobars are relatively the same distance apart. That is very indicative of a generalized rain shield event, not a lot of severe convection. So I would err towards the Euro, looking out this far out. This is Friday of next week, but that's the type of things you look for when you're forecasting severe weather this far out, because that's a mesoscale, a small scale, small time scale event that you're looking out on a synoptic level. So this is all just conjecture at the moment, but it's always good to get an eye of what to expect before it's right on top of you. But the main thing to expect for the next 5 days is going to be temperatures, and they're going to fluctuate quite wildly over the next 96 hours. So we see that these are our maximum temperatures predicted by the NDFD. We'll move forward in time. This goes in a sequence of days. So this would be the maximum temperature we're expecting. We're expecting for today, mid 40s, 50s, 60s at the coasts, and then we see the air start to be channeled in from the central plains. This is looking at tomorrow. These are generalized maximum temperatures, so we're looking like mid 30s in the Carolinas, all the way down to the mid 30s, down into the deep south as well. Coastlines will be down in the 40s. And then we slowly start to, as that air mass modifies and we have warmer air building up on the western tier edge, it'll start to be very different. We see the full extent. This is Monday. This is where we're expecting that ice storm in the Midwest. That's why these temperatures are right on that line. And generally speaking, actually, I would say that a lot of what probably is dictating these lower temperatures and not milder inherently is because there's just a lot of snowpack on the ground. If you look at a satellite view, I might be able to pick one up real quick. Let's look at a satellite view. And true color. Yeah, so you see that there's a ton of snow that's on the ground, denoted by the stationary whites that you see That is snowpack that's on the ground, and snow generally, obviously, makes the air around it much colder. So much like if you were to have ice near you, you would expect the air around the ice to be cold. So this area is probably influenced quite a bit by the snow that's already on the ground, and that's going to influence, generally speaking, probably a lot of the cold air at the surface, which should actually act to freeze whatever is coming down. That is generally probably the main driver of the icing risk. So as we move forward in time, though, this is Monday, Tuesday. We're in the 50s again, 50s in the Carolinas, 60s in the Deep South, 70 in Jacksonville. We got the Wednesday of next week. Look at these totals, and these are crazy anomalies because we'll be in the 45 Indiana. These are regions that are, generally speaking, like 10 to 15 degrees above normal. And then we go way into Thursday, and this is when the southeast is supposed to get hit with most of its moisture from that high pressure sitting off of the coast. 63, 70s, mid 70s, almost 80 in Jacksonville. These are crazy numbers. We'll probably have heat records broken by this time next week. Absolutely crazy. El Nino, sudden stratospheric warming event, polar Pacific jet. All of these things come together. IOD going negative in the Indian Ocean, MJO bouncing all around, Madden-Julian oscillation. All these teleconnections just going haywire all at once is kind of making our weather go haywire here in the States. So definitely got a lot to look forward to in terms, we always do, for us here in the Southeast, but certainly makes it exciting to talk about. Well, folks, once again, my name is Zach with Great Atmosphere. I really do appreciate you tuning in. I would appreciate any leave a comment or subscribe to the channel, specifically maybe if you live in the Southeast. That's where I'm going to be doing the majority of these daily or at least weekday forecasts here in the future. So I really would appreciate your subscription and your continued support. And I will see you next Monday for another forecasting video. Take care. Have a good weekend.